In the animal kingdom, one of the keys to survival is to outwit your enemies. And when you're surrounded by carnivores, one of the best strategies is to fade into the background and disappear. Correspondent Jake Ward met some animals whose mastery of disguise is so sophisticated it could be a sign of a surprisingly complex brain.
When it comes to animals, we humans tend to think we know which ones are the most intelligent. Our own pets.
Give me 5.
Good target. Oh, good target. Good boy.
And most of these smart pets have one thing in common. They're all mammals, just like ourselves. But invertebrates, they don't get much respect. Take mollusks, for example. It's hard to imagine a whole lot of mental activity in a clam. But get ready to meet the Einsteins of mollusks with their incredible brains. The cephalopods, cuttlefish, squid, and the amazing octopus.
It's this wily creature with 8 arms, 200 suckers per arm. Every sucker is highly malleable. They have enormous brains, and there's a lot of complexity there, including intelligence, cognition, and it's the big brain that imparts that.
Here at Biomes, an aquarium and science center in Rhode Island, educator Mark Hall has been studying one of his star attractions, Ruby the octopus. And by the way, Ruby is a boy.
Octopuses are absolutely smart. They exhibit intelligence. I see them problem solve, which is the most impressive part. They teach themselves how to fix problems. There's a lot of signs of intelligence there without doubt.
One problem Ruby has learned to solve is unscrewing the lid on a glass jar that holds a tasty little shrimp.
Here's a jar. He knows it has food in it, but there's a cover on it. I don't teach him how to take the cover off. I give it to him and say, go ahead, see what you can do. And at the beginning, he would twist it the wrong way and tighten it. And he used to do that about half the time, which makes sense, right?
Right.
And as time went on, he did it less and less often, until now, he never twisted
Now he's
the
like,
wrong way.
lefty-loosey, I got this.
It's learning from its successes and its failures, and that's definitely problem solving. Want to try it?
Yeah, I do. Can I try that? All
All
right.
right, so you're going to just put it in the tank.
Right. Oh,
There you go.
oh, there it goes. Whoa. Holy cow.
All right, now he's reaching in.
Whoa.
Placed
The
it right into his
never
mouth.
had a chance.
You notice he's holding the cap.
Right.
And see the arm, making sure
I
there's
love
nothing
it.
in the jar.
He's
Yeah.
double checking. He just hangs onto the cap like a guy who twiddles his fork for a while after he's finished eating. Wow. But it's one thing to solve the problem of eating lunch.
Think of it that way.
It's another to figure out how to avoid being lunch. So these cephalopods have evolved a way to avoid being attacked in the first place. They use brain power to create camouflage. Check this out. A predator prowls a reef. His eyes miss nothing. His teeth are razor sharp. And he's hungry. A fat, juicy octopus would give him enough protein for days. But there's nothing in sight. Or is there? This is no Hollywood special effect. It's the remarkable cephalopod brain at work. As captured on video by Woods Hole marine biologist Roger Hanlon.
The visual deception was really, I think, pretty good.
Yeah, it's incredible. How did you know it was there?
I'd been following this animal for almost 45 minutes.
It's just skipping from good spot to good spot for
Exactly.
camouflaging itself against the background.
Oh, no. Actually, it's going good spot to find food, but it can camouflage anywhere on any background. But it all happens in about 7/10 of a second.
The video allows Roger to analyze this amazing 7/10 of a second transformation.
So let's do this slow motion reverse and try and break it down to understand what's happening. So here you see the animal sort of all white and smooth.
Right.
Now watch the ring develop around the eye. There it is right there.
The animal uses its brain between the eyes to transform its three-dimensional shape, color, texture, and pattern. Individual neurons in the brain travel directly to the skin, sometimes long distances of a meter, without having to jump breaks called synapses. So it's doing all of these things, pattern, color, brightness. It's dealing with all of that with that brain in 7/10 of a second.
Right, and this is the puzzling part of that. How does this brain, which is large but not a brain the size of this room, accomplish all of this? That's really the mystery.
It's a mystery because they would need a brain the size of a supercomputer to process all that visual information and to mimic it so fast. So how do they do it? Roger followed a hunch based on a biological principle called parsimony. The idea that nature works out efficient, simple ways to accomplish complex tasks. Guided by this principle of parsimony, Roger chose to study a cephalopod called the cuttlefish.
Made this decision?
He zeroed in on one component of their camouflage, the pattern. And Roger now believes he's found the secret. They simplify their choices by using just 3 pattern types. Uniform, which has very little contrast. Mottled, which has light and dark bits. And the one with the greatest contrast, disruptive.
You want to go from uniform to...
To control the area and contrast the animals are exposed to, Roger places them against backdrops they would never encounter in nature.
Hello, buddy.
With each one, the animal changes its pattern, usually in mere seconds. Uniform, mottled, disruptive.
Look at that, and there,
Well, the animal changed magnificently.
immediately.
So it's created a mosaic out of itself.
I noticed that the white square on its back is roughly the same size as the checkerboard pattern.
Yes.
So if this were a bigger cuttlefish, you'd need a bigger checkerboard pattern to set this off.
Yes.
The animal's brain measures the amount of contrast in its surroundings and then alters its skin to display a similar amount of light and dark.
We say this is a window into the brain because the skin is a representation of the neural activity. This takes a lot of neural processing, takes a lot of decision making, and this is what we call cognition and thinking, and it all translates into some form of intelligence.
Intelligence. Someday we'll have a better understanding of how it enables cephalopods to change their physical appearance so radically, and how they use their brains for other tasks we're just beginning to identify. Recently, Australian researchers documented what looks like evidence of the ability to plan. An octopus in the wild, making a tool out of a found object, a coconut shell, and planning how to use it, for shelter as well as disguise. Maybe, just maybe, cephalopods are more intelligent than we realize.